Hi, everyone, and welcome to Rates of Change, our first application of derivatives. This is the biggest and most important application of derivatives that we're going to learn. On the AP Calculus exam, there are 6 open-ended questions, and this is always one of them. So we're just barely going to touch on more like an introduction today. I don't want you to walk away at the end and say, that wasn't that bad, but they will get harder, but this is going to be an introduction to the concept. If you're taking physics, these concepts might already be very clear to you. So the first page, as you can see, there's not a lot of room for you to write. It's mostly, sorry, just me talking. So distance is the function s of t, gives the position s on a line as a function over time t. So when you see s of 3, that literally means where an object is at x is equal to 3, or I should say time is equal to 3. Not that x is equal to 3 is wrong, just we usually use t in these problems. Versus displacement, which is how far it traveled. I would say on the next unit test, displacement is the most missed question. It's just a little tiny 1-point question. But people like to give me s of 3 instead of, say, s of 3 minus s of 0, meaning you need to know where you start. So it's where you finish minus where you start, which I know makes a lot of sense, but for some reason people just don't do it. So where you finish minus where you started will give you your displacement. Velocity is the derivative of the position equation because velocity describes how fast the position is changing. There are 2 different kinds of velocity. There's average velocity and instantaneous velocity. This is how I keep them straight. Average velocity can be done by average people, meaning you guys have been doing average velocity for years. If I sit there and say, all right, I'm driving to Cape Cod. This is my time that goes by. This is my distance. And so I take off. It's a little slow in the beginning. There's some traffic on 202, but then I get on the highway and I'm able to cover a lot of distance in a short amount of time. Anybody know what's happening here? I stop, right? My distance continues, or my time continues, but the distance doesn't increase. And then I get back on the highway, going at a good speed. And then maybe that slope changes as I get into downtown Falmouth, which is in Cape Cod. And eventually I get to my ending location. So nobody needs that graph to figure out what my velocity was on the way to Cape Cod. They just say, all right, it's a 300-mile trip. It took me 6 hours. So my average velocity was 50 miles per hour. Okay, don't think that I drive that slow. It's just that, remember, it's an average. So it counts for that stop. It accounts for leaving the neighborhood and stop and go traffic on 202. And then, when you're in the little towns on Cape Cod, only the highway is going to have a higher than that number. How do we find average velocity graphically? It's literally this average slope. Okay, average velocity is that. But if I said to you, what is the instantaneous velocity at hour 3? Exactly how fast was I going at hour 3? So if this had marks on it, and I said, I want to know exactly what was happening right there, the slope right there. Well, it looks like right there I was on the highway and I was going faster than my average, which was 50. Remember the green line, if that represents 50 miles an hour, my red slope right there is faster. Where in hour 1, my slope was slower. That would be instantaneous velocity. That's the whole purpose of the derivative. To be able to say, I don't want to know the average slope. I want to know the slope right at that second. So average people would do average velocity, but you're in calculus. You can find instantaneous velocity. Velocity does have a sign. It's positive when an object is moving up or forward, which we're going to say is to the right. And if an object is moving back, which we usually interpret as left, or down, then when we say the velocity is negative. Now, obviously, when I'm coming home from Cape Cod, I don't say my velocity was negative 50 miles an hour. That's because normal people use speed. Speed is the absolute value of velocity. So it pretty much says, yeah, I don't need the positive or negative sign. The positive or negative sign gives you direction. So if you don't have the positive or negative sign, if you choose to omit it, then you're just giving me the speed. All right, so there's three parts to this. There is distance, which I did not choose this, but they use S, velocity, and then acceleration. I'm going to refer to this as SVA all year long. So if you have a distance equation, S of t, or sometimes they use x of t, then if you take the derivative, you can find the velocity. And if you take the derivative of velocity, you can find acceleration, which is the second derivative of the distance. So here's the little code for it. Acceleration is the derivative of velocity with respect to time, which is the second derivative. So the top one is squared because you're doing the second derivative. The bottom one, they put the square in a different place because now that's the unit. It's with respect to time squared. So acceleration would be feet per second squared, miles per hour squared. So if you were in class, I would be standing in front of the room making a little bit of a fool of myself, but doing something really, really important, which is if I were standing somewhere and I wanted to change my distance, I wanted to move to another part of the room. So I'm here standing at spot 4 and I wanted to get to spot 7. Then how do I make that distance happen? I need velocity. Velocity is what changes distance. Velocity is what changes distance. And change means slope, and slope means derivative. But what if I wanted to change my velocity? What if I'm already kind of going pretty fast here? I don't know. Does that look good? That probably looks bad. So I've already got a velocity of, say, 10, and I wanted to have a velocity of, say, 15. How do I change my velocity? I accelerate. So acceleration changes velocity. And that's why you can take the derivative of velocity and find the acceleration. So a lot of people don't get these concepts on the first try. Today's just an introduction. We'll come back to it 20 more times before the end of the year. So don't worry if you don't completely have it today. But as far as examples go, it's just this easy. If you have a distance formula, then the velocity is 32t. The acceleration is just 32. You can try the next two on your own if you want to. Velocity is 32t minus 60. And acceleration is 32. On the last one, velocity is negative 32t which means it must be going to the left or down, plus 832, and the acceleration is negative 32. So 32 came up a lot. This is probably not an important number in your world. I suspect you guys know 9.8 meters per second squared. This is acceleration due to gravity. You might have learned it in a science class, but most calculus things still use the English standard system, And in English Standard, not metric, this number is 32 feet per second squared. So if an object is falling, every second it falls 32 feet per second. That's the acceleration due to gravity. So then the next second, because it's second squared, it's going to fall even further. So we'll do an example and I'll make that a little clearer. So this is a general formula. It doesn't say S of t, but you can think about it as S of t. So velocity is, bring down the 2, but it cancels with that 2, gt plus VO. And then acceleration would just be g. So when you see this formula in a science textbook, the g always stands for gravity. The VO stands for the original velocity. So if something has a velocity and then plus gravity works on it every second, this would give you the final velocity. And SO is the original position. So if you see this in a physics or science textbook of some kind, that's where this formula comes from. Now you understand it from a calculus point of view. Let's do an actual problem. A heavy rock is blasted vertically upward with a velocity of 160 feet per second. It's positive because it's going up. So somebody has this rock, they blast it upward. Its original velocity is 160 feet per second. It reaches a height of S is equal to 160t minus 16t squared after t seconds. So this is a great formula. This tells me its height at any moment in time. So if I say S of 1, that means after 1 second, how high is it? That's what that would mean. We want to know, how high did the rock go? Well, think about what's going to happen. It's going to keep going up and up and up, but it's losing speed. Why? Because gravity is working against it. Gravity is negative. So every second that goes by, it loses some of that velocity until its velocity at the top is what? It was positive, and then all of a sudden its velocity is 0. It slows down so much it has no velocity, and then it starts to come back down. Now, at first, it has some negative velocity. It's not going very fast. But by the time it lands, it's got some serious negative velocity. So I want to know how high the rock went. I can use this concept. When it's at its peak, its velocity is 0. So I take the S formula and I take the derivative. S prime of t will give me velocity. So 160 minus 32t. When is that equal to 0? Remember, the velocity being equal to 0 is when it's right at the top. It had a positive velocity, kept slowing down, got to 0, and come back down. So I want to know when the velocity is 0. T is equal to, did I write that down? 5. So did this answer the question? No, it only answered the question, how many seconds? So it was 5 seconds until it reached its maximum height. It was going up for 5 seconds, and now it's going to come back down. So how high did the rock go? You want to know its position at 5 seconds. This would represent its position at 5 seconds, which we know is its max. So you can do 160 times 5 minus 16 times 5 squared. And when you do that, you should get 400. Don't forget your units. This problem is in feet. All right, let's do number 6. The position of a body at time t is s is equal to t cubed minus 4t squared minus 3t. Find the acceleration each time the velocity is 0. So sometimes even before I read the question, I just write all 3 equations. Velocity is 3t squared minus 8t minus 3. Acceleration is 6t minus 8. The question says, find the acceleration. So as soon as I see this, I know I'm going to be doing a of something. Each time the velocity is 0. So when is the velocity equal to 0? When 3t squared minus 8t minus 3 is equal to 0. All your years of factoring are going to pay off. It has to be 3t and t. Has to be 3 and 1. That'll give me t and 9t to give me 8t if I make this one negative and this one positive. T is either equal to negative 1/3 or 3. Can t be negative? No. So the only viable answer is t is equal to 3. So what is the acceleration when the velocity is 0? 6 times 3 minus 8, which is 10. This one doesn't have any units attached to it, so you can stop there. Another vertical motion one. This one you very much can try on your own. So I am going to just give you the 2 answers, 45 meters and negative 10 meters per second squared. Would love for you to try this one on your own. So sometimes they use h of t instead of s of t. Same as s of t. They like to use it when they're doing something going up in the air for height, which is also the same as x of t. So those are the 3 common uses for s of t. It doesn't always stay one or the other. So again, I like to write my 3 equations off to the side so I have them kind of like a reference. So velocity at any time t is going to be 30 minus 10t, and the acceleration is going to be negative 10. Notice that the t is no longer in the acceleration equation. That means the acceleration doesn't change depending on t. Acceleration is a constant, kind of like if I gave you the question graph y is equal to negative 10, you'd say, oh, that's a horizontal line at negative 10. It just goes like that. It's constant. It's constantly 10. So since this is a constant function, you can actually answer part B already. The acceleration is always negative 10, no matter what the velocity or no matter what the time is. So this one is just like what we did before with maximum height of the ball. The ball reaches a maximum height when the velocity becomes 0. So it's going up, right? It's going up. It has a positive velocity all the way up. It's getting slower, has a negative or a 0 velocity at the top, and then it starts to have a negative velocity as it comes back down. So I'm going to set the velocity equal to 0. 30 minus 10t is equal to 0. T is equal to 3. What is the maximum height? If they want to know maximum height, you need the height equation. So since I want to know the maximum height, use the h equation. So there's a lot of different equations, and sometimes people's biggest problem is just using the right one. So I want to know the height at 3 seconds, because at 3 seconds, that's when its velocity is 0. 30t minus 5t squared. Oh, I didn't actually fill it in. 30 times 3 minus 5 times 3 squared, which is 90, minus 5 times 9 is 45, which is 45. Make sure you have the correct units. In this case, it's meters. I hope this is making some sense to you. We have one more. Horizontal motion. A particle moves along a line so that its position at any time t greater than 0 is given by this function. So I'm actually going to go back for a minute and just try and make some kind of clarification. If a ball is thrown vertically upwards, then it literally goes up and it comes back down. When you see the graph of h of t, even though this is the actual motion, h of t is a downward parabola that looks like this. So sometimes people think that this represents the path. This is not the path. This is the path. It just goes straight up and straight back down. This is a graph showing you its height over time. So when time is 1, this is its height. When time is 2, this is its height. At time 3, this is its height. This is not the actual path. This is just its height at different times. So on this one, S of t is again a parabola. So we can quick graph it. S of t is equal to t squared minus 4t plus 3. I can make the graph by setting it equal to 0 and factoring. So I can find the intercepts. T is equal to 3 and 1, 1 and 3. So whatever it does, it looks like that. So this, and where's that point? Oh, I made it go down. Huh, it doesn't go down. Because I checked my y-intercept. Its y-intercept is positive 3, and it is an upward parabola. It's not a ball going in the air. It's something moving on a number line. So this graph, the graph of S, tells you where it is on the number line because it's horizontal motion. So this one's a little tricky. So here's my number line. 0, 1, 2, 3, 4, 5. 1, 2, 3. So this particle, whatever it's doing, starts right here. At t is equal to 0, that's where it is. And we know that it actually moves backwards. Look at this graph. This is telling you it's describing its motion. So it's actually going down, and then at t is equal to 1, this is its S, and this is its t. At t is equal to 1, it's 0. And it keeps moving backwards. So it's going this way until, I don't know what that point is. I can find that point, but I don't know it yet. But it's going backwards, and then eventually it's going to come back forward when at t is equal to 3, it's going to pass that 0 point again, and then it continues to go forward for a really long time. So this is important that you understand this motion, very different from just throwing a ball in the air. I'll say it one more time, so if you got it, maybe you can skip ahead. But it's starting at 0.3, but on a horizontal line. So it's right here at 3 at 0 seconds, and it starts to go down, and at 1 second it's at 0 on the number line. It keeps going backwards, and then somewhere around here, looks like maybe at 2 seconds, it turns around and it starts to come back up. I don't know how far back it goes, and then it'll come back up. Okay, let's start answering the questions and see if that helps. Find the displacement in the first 2 seconds. Whenever you see displacement, you should be thinking the final minus the original. So S of 2 minus S of 0. What was its position at 2 and what was its position at 0? So we already know that where it started, if I plug a 0 in, I get 3. If I plug a 2 in, I get 4 minus 8 plus 3. So its displacement in the first 2 seconds comes out to be -4, if you do that math. Its unit is meters. That was a little sloppy. So it moved back 4 meters. It moved backwards 4 meters. That's what that negative means. Moving on to part B. Find the average velocity in the first 4 seconds. So when it says to find the average velocity, remember, average people can do it. If I were going to Cape Cod, you would just tell me what is the total distance divided by the total time. Average velocity is just the change in distance divided by the change in time. Average people can do it. So don't use any fancy calculus. How do I get that change in distance? Well, it's the first 4 seconds. So I want to know where I ended, where I started. That'll give me my change in distance over the 4 seconds. So using the actual slope formula, you want it to look like that. So S of 4 is 16 minus 16 plus 3 is 3. S of 0 is also 3 over 4 is 0 over 4 is 0. So this looks a little funny. People sometimes struggle with this concept. They say, well, that can't be the average velocity because I know it was moving. It definitely had a velocity. No, it definitely had a speed because speed doesn't account for positive and negative. In this case, the average velocity must have come out to be 0 because the amount that it had negative velocity must have equaled the amount that it had positive velocity to average out to be 0. So it can have an average velocity of 0 meters per second. Don't forget your units, even when it's 0. Part C, find the instantaneous velocity. Now you get to use your calculus. So we didn't do this right at the beginning, which I know I said that I always do, but I didn't. Let's find the 3 equations. So I take my S equation, I just like to have it off to the side, is t squared minus 4t plus 3. I really do like to start problems this way usually. 2t minus 4, and acceleration is 2. Notice that acceleration came out to be constant again. That means time doesn't matter. At all times, the acceleration is 2. So that actually means I can answer part D now. The acceleration is equal to 2 meters per second squared all the time. So now part D is done. But moving on to part C, what is the instantaneous velocity when t is equal to 4? Instantaneous velocity is always derivative. You want to know something right at that moment in time. So v of 4 is equal to 2 times 4 minus 4 is equal to 4. Make sure you have your units, meters per second. Great. Part D we already did. So moving on to part E. Describe the motion of the particle. So I actually tried to do this in the beginning, but we left out a key element. We knew it was going backwards, and then we knew it was going forward again because we looked at the graph and we tried to compare it. This specifically says, at what value of t does the particle change direction? So here's a key concept I want you to understand. If something has a negative velocity and then it has a positive velocity, what must have happened right there? Its velocity must have been 0. That's always the way to find out when something changes direction, whether it's going up in the air and then changes to down in the air, whether it's going left and then changes to going right. The only way for it to change is for it to stop. Even if it's just for a split second, it has to stop before it can turn around and be going the other way. So when is the velocity equal to 0? Remember the velocity equation's over here on the side. 0 is 2t minus 4. T is equal to 2. So to describe this motion, the particle starts off going left. After 2 seconds, it stops and then goes right. So again, let me just try and make that clear with this graph up here. So it starts off at 3 on the number line. It's going down on this, but we know that because this is representing horizontal motion, that means it's going left. Left and down are the same. So it's going left until 2 seconds, which we had predicted, and then it starts to go right again. So where does it actually reach? Remember, we didn't find that out yet. We just know that at t is equal to 2, it turns around. Where is the particle at a minimum? When t is equal to 2, but we need to actually find that value. So we know it's a minimum when t is equal to 2, but if you want to know where it is, then you're going to use s of 2. So at 2 seconds, let's find out where it is. 2 squared minus 4 times 2 plus 3. 4 minus 8 plus 3. Where is it? It's at -1. So it goes like this, and then it turns around. It didn't get quite that far. Okay, it turned around at -1. So very, very new concept. Unless you take physics and you thought, she spent way too long on that. I understood that right from the start. But for those of you that don't take physics, I hope I took my time and explained it. But if you still don't quite get it, I cannot stress enough, we're going to keep coming back to this concept. So don't panic. All right. Have a great rest of the day.